Once we get it all factored and simplified the right way, and we get 0 on this side, it's pretty easy to do the key points on a number line. The key points are the places where this thing is undefined and 0. So those are -2, 1, 0, and -1. So I'm going to put it on -2, -1, 0, and +1 are the key points. Now I need to test to find out if it's positive or negative in these regions. So pick a number less than -2, like -3. -3 would give you a negative there, a negative in this quantity, a negative in the bottom here, and a negative there. So that would end up being positive because there's 4 negatives. Double negatives cancel. Now pick a number between -2 and -1, like -1.5, -1.5, right there. If I pick -1.5, this would be positive right there. This would be negative, right here. This would be negative, and this would be negative. So 3 negatives make a negative. Okay, so now I'll pick a number between -1 and 0, like -0.5. -0.5 up here would give you a positive. -0.5 here would give you a negative. -0.5 here would give you a negative. And -0.5 here would give you a positive. Double negatives go positive, so this would be positive. And usually these alternate, by the way, not always. Sometimes with the asymptotes they won't, but usually they alternate. So now let's pick a number between 0 and 1, like +0.5. +0.5 gives you a positive here, a negative there, a positive here, and a positive there. So this would be negative. Now let's pick a number bigger than 1, like 2. If you pick 2, this would be positive, this would be positive, this would be positive, and this would be positive, so that would be positive. So now we're answering the question, when is this function less than or equal to 0? So what we want is wherever it's negative, from here to here, and from here to here. Now, we have to be careful because some of these places are undefined and not zeros. So, for example, 0 right here is undefined in this function, so we can't include that in our interval. And -1 right here is also an undefined value, so we got to make sure not to include those points. So we're going to go from -2 to -1. We can include -2 because that's less than or equal to 0, and that's a 0. So we're fine to include that one. We can't include -1 though because that's an undefined value. We need the union symbol, and then we need to go from 0 to 1. We can include 1 because that's a 0, and we can include the zeros. But we can't include 0 because that's a place where this function is undefined. So there's our final answer right there. All right, so then let's try one more of these then, or another one. You're tempted to clear fractions in this one and multiply through by x minus 6 times x minus 5. But that we can't do that because we don't know if that's going to switch the sense of the inequality, being that it could be a negative number. So you're tempted also to cross multiply. Once again, we don't know if we're multiplying by a negative or not, so we can't do that. What we can do is subtract both sides by 1 over x minus 5. Okay? So it would be 1 over x minus 6 minus 1 over x minus 5 is less than or equal to 0. Okay? Now I'm going to combine these fractions. To do it, I need a common denominator. So I'm going to multiply the top and the bottom of this one by x minus 6. And I'm going to multiply the top and the bottom of this one by x minus 5. So that gives me x minus 5 minus x minus 6 in the top, all over the common denominator, x minus 5 times x minus 6. And that's less than or equal to 0. Okay, so now I'm going to simplify. I'm going to have x minus 5 minus x plus 6 in the top, all over x minus 5 times x minus 6 in the bottom is less than or equal to 0. The x and the negative x cancel, and you have negative 5 plus 6, which is 1. So the top just simplifies to 1 for me. Okay, now we do our key points on a number line. The key points are the places where this is 0 and undefined. So that would be 5 and 6 in this case. And they're both places, you might want to write this down every time underneath. Those are places where this is undefined. Keep in mind, that's going to matter for our answer. So let's pick a point underneath 5, which is like 0. If you pick 0, you get 1 over 0 will give you a negative there, and will give you a negative there. Double negatives would cancel and give you a positive. Now I'll pick a number between 5 and 6, like 5.5. 5.5 would give you a positive in this one, but a negative in this one, so that'd be negative. And then 6, a number bigger than 6, like 7. If you pick 7, 7 will give you a positive there and a positive there, so they'll give you positive. So when we're asked when is this less than or equal to 0, we'd say from 5 to 6. But we can't include either of these points because they're undefined. So I'd have to use parentheses there and not include those points. Now, if you try to do this from a graph, you can do this from a graph. It's just, I think, harder. It's up to you. But what you do is you graph both of these and find out where the 1 over x minus 5 is bigger. So if you look at that, here's both of them graphed. We want to find out when the blue one's bigger. Now, it turns out the blue one's, it's really hard to see, but the blue one's only bigger from 5 to 6, right in this range. And the reason why is because at 5 is that the blue one has an asymptote and jumps to positive infinity. And so the blue one's bigger than the red one from 5 to 6 right here because the red one's still down here. But at 6, the red one has an asymptote and jumps to positive infinity and gets bigger than the blue one again. So only from 5 to 6 is the blue bigger than the red, which is very hard to see from this graph, which makes it a good one to put on the test because you really have to do it algebraically the way that we did it. Not by cleaning fractions, but by subtracting this over. All right, so the next one, let's do it again. This time, once again, you're tempted to clear fractions, but don't do that because we don't know if it switches the sense of the inequality. So we have to just do this algebraically. We have 6 over x minus 1 minus 6 over x, and we're going to subtract 1 from both sides and find out when this function right here is bigger than or equal to 0. All right, so to do this, we need a common denominator. We're going to multiply the top and the bottom of this one by x times x, or x minus 1 times x. That's still 1. This one we're going to need to multiply the top and the bottom by x minus 1 to get a common denominator. And this one we're going to have to multiply top and bottom by x to get a common denominator. So we end up with 6x minus, I'm going to distribute this negative 6 to both terms. So they give me minus 6x plus 6. And I'll make this plus or minus as well and distribute that. So that gives me negative x squared plus x all over x times x minus 1. So now I can simplify this. This turns into negative x squared. The 6x and the negative 6x cancel. I have plus x plus 6 all over x times x minus 1. Want to know when that's greater than or equal to 0. Now, whenever I have an x or a negative sign in front of x squared, I always factor that out. So I make it negative and I put this in parentheses, which would make this negative and this negative. I think it's easier to factor that way. And then it factors into two linear factors. It factors into x, and then we need minus 3 and plus 2. So now from there we can put our key points on a number line. Our key points are 3, negative 2, 0, and 1. So I'll put negative 2 here. I'll put 0 here, 1, and 3, all on a number line. So now let's pick a number less than negative 2, like negative 3. Let's find out what this is, positive or negative. So that negative has to stay there. All right, so that negative is always going to be there. Now, when I stick in negative 3, this would be a negative right here. Negative 3 would give me a negative there. It would give me a negative in the bottom and a negative in the bottom. So that's 5 negatives, so overall that's another negative right here. Okay, now let's try sticking a number between 0 and negative 2. So like negative 1. If we stick in negative 1, that negative's still there. This would be a negative. This would be positive. This would be negative. And this would be negative. So that's 4 negatives, so that'd go positive. Okay. Now let's try sticking in a number between 0 and 1, like 1/2. If we try sticking in 0.5, this would stay negative. This next factor would be negative. This would be positive. This would be positive, and this would be negative. So that's 3 negatives, which once again is a negative. Okay. Now let's try sticking a number between 1 and 3, like 2. If you stick in 2, this would be negative, this would be positive, this would be positive, and this would be positive. So that's 2 negatives, which is back to positive. Now let's stick in a number bigger than 3, like 4. Stick in 4, this would be negative, this would be positive. I'm sorry, this would be positive as well. 4. Positive, 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 and positive, so that'd be negative. Okay, so now we can answer the question, when is this thing greater than or equal to 0? Before we do though, negative 2 was a 0. 0 is a place where it's undefined, 1 is a place where it's undefined, and 3 was a 0. That's important to know. So now when we're looking at when is this thing positive, we're looking at this branch right here, and we're looking at this branch right here, but we can't include the places where it's undefined. So that'd be a closed circle, it'd be an open circle, this would be an open circle, this would be a closed circle. So our interval will be from -2, close bracket, to 0, open bracket, open parenthesis, as well as union from 1, parenthesis, not including that point, to 3, including that. So there's our answer. All right, next question is an easier one then. It says to match these with your multiple choice one. So x is any real number. Well, that's D right here. Any real number is negative infinity to positive infinity. Okay. The distance from x to 9 is more than 3. That'd be B. The distance is really just subtract the numbers and make it positive, which is what this is. Subtract the numbers and make an absolute value. That's how you find the distance between two numbers on a number line. You know, if this is x and this is 9, you want to find the distance, just do 9 minus x or x minus 9. Doesn't matter. Just make it positive. Okay, so that's B. X is greater than 9 is a pretty easy one. That's E. And then x is less than or equal to 9. That's C. And then x is greater than or equal to 9. That's A. All right, another easy one then. That's already factored for you. This is a cubic function. We know what it looks like. We know it has a 0 at 0, and 1 at -6, and 1 at +6. So the function looks like this. And we're asked to solve this. We're asked when is it negative? Well, it's negative from negative infinity all up to -6, and it's also negative from 0 to 6. But let's pretend we don't have the graph in front of us, and let's do it algebraically again. So we're going to look at key points. The key points are the places where it's 0 or undefined, so that'd be -6, 0, and 6. Let's pick a point beneath -6, like -7. That'd give me a negative times a negative times a negative, which is negative overall. Then let's pick a number between -6 and 0, like -1. -1 would give me a negative, a positive, and a negative, which goes to positive. Pick a number between 0 and 6, like 1. 1 gives me positive, positive, negative, so that'd be negative. Pick a number bigger than 6, like 7. It gives me positive, 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 which would be positive. So when they ask when is this thing less than or equal to 0, I'm looking for the negative branches. And these are all zeros. So I can include those because it says less than or equal to. So I would go from negative infinity all the way up to -6, including -6. And then union, capital U, from 0 all the way up to 6. And we can include both of those points because they're both zeros. So there would be our answer for this one. All right, the last problem then is just testing the same thing, but with domain. So if we were to find the domain of this function right here, we know that we can't have negatives underneath square roots. So we'd have to take what's underneath there, which is x minus 2 times x plus 8. We'd have to make sure it's greater than or equal to 0, because otherwise, if it's a negative, it's undefined. So we're solving this inequality, essentially. So once again, we'll put the key points on here, which is 2 and -8. And we'll test the region. So beneath -8 is -9. Gives me a negative and a negative, which is positive. In between -8 and 2, like 0, gives me a negative and a positive, which is a negative. And above 2, which is 3, gives me a positive and a positive, so that'd be positive. So when is this thing greater than or equal to 0? We'd say from negative infinity all the way up to -8. We can include -8 because that's a 0, and it says greater than or equal to 0. As well as capital U for union, from 2, we can include that to positive infinity. The reason we include 2 is because it's a 0 again. So there's our domain. There's where this would be positive, and those are the numbers that we can stick into this square root as a result. All right, I hope this helps.